Good afternoon, November the 18th, a lovely Saturday, where SpaceX just made a very successful launch of their Starship, the second one. Very good. When I read this problem, I thought immediately, oh, but this is just the group mapping infinity to infinity, so isn't that all trivial? And then I read the mode n. I still think it's trivial, by the way, which I'll explain in a minute. So now let's explain that first. First we need to find alpha, but mapping infinity to infinity, that's done by the, where is that? Yeah, that's done by the identity matrix, so alpha can be disregarded totally. So we need to find gamma mark the part of gamma, or what is it called really? Gamma mark that maps infinity to infinity. And then we have to have a naught here, not just naught node n. That means that this must be a unity. So that means that if we just take the subgroup generated by minus t to jth, I think he writes it like this. Then that's the stabilizer group for infinity. And it obviously has the right form, corresponding to case 2b. So there was nothing to it. What I wanted to do then was to describe gamma mark in case n equals 4. And then we have two possibilities for h. So let's see what are the groups in question here really. And the second thing was n equals 2. What goes wrong? Nowhere in my argument did I say, and for this reason n has to be larger than equal to 4. So that indicates that I missed a detail. Let's start with the second one. If n is 2, then h is unity. So gamma mark equals those that are equivalent to minus t. Oopsie. The matrix is equivalent to minus t to nth modular 2, but this is of course the same as t, it's equivalent to t modular 2, so it's not case, it's actually the first case we are dealing with here. I was not very careful there. Then let's try the next thing. N equals 4 and h equals 1. So we are going for a level 4 group. Ah, come on, that's just minus t to jth modulo 4 that means it's equivalent to t minus t squared minus t to the third t to the fourth now. I thought if we it's a subgroup, yeah, let's notice that. It's a subgroup of gamma naught of 4, level 4. We do have the generators of gamma naught. I'll just fetch the book. This is problem 13D of the first section in chapter 3, and they're generated by T, of course, which doesn't lie in this guy, and I don't know about the signs. But then on the other hand, it's modulo plus minus 1, which of course lies in gamma naught of 4. So it's also generated by minus I, t, and then 1, 4, 1, naught. That's st to fourth s, or maybe minus, or maybe to the first. I think it's actually to minus fourth I'm having here. Oh, that's what it says in the problem, yeah. Of course, this guy lies in gamma mark, being equivalent to the unit matrix modulo 4, but t doesn't lie in it, as minus 1 doesn't. So it's actually a subgroup. I believe this group is generated by minus t and this guy. So let's skip that. And then that was h equals 1. Oops. And h equals 2. Is that really interesting at all? Nah, it's just generated by t square, and yeah. and this guy, of course. So let's leave that. All right, that was all I had to say to problem 3.